Hello. So now we're going to do this problem. Okay. Normal distribution example 2. Suppose that the nutritional content of a croissant in terms of sugar follows a normal distribution with mean 0.5 grams and standard deviation 0.1 grams. What is the probability that the croissant has between 0.475 grams and 0.515 grams of sugar? Okay, so the first thing we're going to realize here is that we want to first state what the random variable here is, and it is the quantity of sugar. Let's call it W again because it's in weight, and we see that it's normally distributed with a mean of 0.5 grams and with a standard deviation of 0.1 grams, right? And again, the reason I'm using this notation is because I want you guys to get familiar with it. I want you guys to be able to observe, like, oh, I see n open parentheses something comma something close parentheses. It's a normal distribution with mean blah, standard deviation blah. Here, the weight of the sugar in the croissant, in a randomly selected croissant, is normal with mean 0.5, standard deviation 0.1. Okay. The question is, what is the probability that the croissant has between 0.475 grams and 0.515 grams of sugar? Okay. So what do you think we're going to do now? I imagine that all of you already suspect. We're going to draw a picture, right? Okay. Because what we want to do in our little sketch is we want to sketch out what the region is going to look like that we want to calculate. Because that's going to help us to determine that's going to help us determine how we're going to do it. Okay. So here's how we're so let's draw that region here. First of all, we know that the mean goes right in the middle always. 0.5. Okay. Now, what is our region of interest? We want to know what is the probability that the croissant has between 0.475 grams and 0.515 grams. So let's say here is 0.475 and here, let's say, is 0.515. Okay, so we can draw like this boundary line here and this boundary line here, and we know that the probability that the quantity of sugar in the croissant is between 0.475 and 0.515 corresponds to the area under the normal curve between those two boundaries. Okay, and this is in terms of our random variable W. Now, again, if you had a calculator, if you were using a spreadsheet, you could calculate these values already using the given information. But we're going to use the standard normal table just because it's a standard technique, and I want you guys to get a feel for this first. And of course, I will have some technology supplements so you can see how these are done with technology. Okay, but for right now, I want us to learn the textbook technique. So now what we have to do is we've drawn our picture. We have shaded the region that is going to capture the probability that is of interest to us. So what we're now going to do is we're going to find the z-score of these values. Okay, so that we recall that the z-score of some value x in the distribution is x minus mu over sigma. Okay, so let's first calculate the z-score of 0.475. And in fact, I'm going to put a little line here so that underneath it I can make like the corresponding z-score values. Okay. Okay. So the z-score for the 0.475, okay, is going to be let me write down the formula first. X minus mu over sigma. Now, one of the things I want you guys to do is I want you to write the formula first, always, and then plug in. Because you want to internalize it in your brain. Okay, so it'll be 0.475 minus our mean, which is 0.5, And then that's divided by our sigma, which in our case is 0.1. Now here I'm going to avail myself of technology. I'm going to use a calculator to calculate this Z-score. And we get negative 0.25. Okay? And then I'm going to calculate the Z-score for the 0.515. Right? So the Z-score is x minus mu over sigma. And that is going to give us 0.515 minus 0.5 divided by 0.1. Using my calculator, I get that that's 0.15. Okay, like this. So here, this will be negative 0.25. The mean here would just be, of course, have z-score 0. And the 0.515 has z-score 0.15 as per our calculations. By the way, so the reason why I'm making these two different tables here at the bottom, I don't know if you could call them tables, but let's just go with the idea of them being tables, is that here, this first drawing that I did captured the problem statement and the values from the problem. Underneath here, instead of drawing a separate normal curve, with the corresponding z-score values and shading the region corresponding to the area of the standard normal that has the same area as the normal random variable that represents the weight of the sugar in the croissants. I just decided to write the corresponding labels underneath. So I can either interpret this, this standard normal with these values as representing the normal random variable corresponding directly to the weights of the sugar in the croissants, and I can also interpret this standard normal I can also interpret this figure using the standard normal values for the purposes of using my standard normal table to calculate the corresponding area, right? Yes. So in other words, with these values, this shaded region will have the area that corresponds to the croissant sugar amounts. Okay? So now in order to do that, so in other words, let me restate that. Okay? Let me restate that in terms of some notation here. Okay? So over here, if I'm talking about this here, right? I know that what I'm looking for is this area, because this area represents the probability that the croissant sugar quantity will be between 0.475 and 0.515. So in other words, I can say that what I'm looking for is the probability that the random variable W is between 0.475, is between 0.475 and 0.515. And then what I'm saying basically is that from what we got here, from calculating the z-scores, we see that this probability is equal to the probability that the z-score takes on a value, or that the standard normal random variable takes on a value between negative 0.25 and 0.15, right? And so now, if you recall from our previous, from one of our previous examples where we were finding the area in the middle, what we did was we took the area to the left of the upper limit, all this area, which we can get from the standard normal table, and then we subtracted the area from here to the left, right? And so that's exactly what we're going to do here. So in other words, what I'm saying is this. The area of interest to us here, that goes from here, I'm going to just use the normal values. So negative from 0.25 all the way to 0.15. this area, this shaded area, is the same as the area under the standard normal curve behind to the left of 0.15 minus, the area under the normal curve to the left of negative 0.25. Right? And then and I hope you appreciate the way I'm drawing these figures, because I want you guys to get a feel for how you do these calculations without getting too bogged down in like formulas and stuff. Okay? So for example, what is the area under the standard normal curve that is to the left of 0.15? Well, we can take out our standard normal table and we can find out what that is. So if I look at my standard normal table, I go to the value 0.1 and then I go along the top to get the second digit to be 5. And I see that the area of the standard normal curve to the left of 0.15 is 0.5596. So this area is 0.5, well, I guess let me not write it here. Let me write it over here. This equals 0.5596 minus, what is this area? I look over here at my normal table, negative 0.25. Here I have my negative sign, negative 0.2, and then 5. I go to the middle here. Okay, here it's negative 0.2 and then 5, 0.4013. And then I'm going to use my calculator to carry out this subtraction for us. Okay. So 0.5596 minus 0.4013 equals 0.1583. So this finally is equal to 0.1583. Okay. Okay. So now we're finally in a position to state the solution of this problem. And that is that the probability that the quantity of sugar in weight in a randomly selected croissant sorry about that. And that is, the solution is that the probability that the weight of the sugar in the croissant that weight lies between 0.475 and 0.515 is 0.1583. Okay? And again, let's recap again how we did that. We looked at our problem statement. We took the values of the normal distribution, the mean and the standard deviation, and the value of interest, and we used that to draw a figure of the normal distribution of interest to us. And we labeled its values, and we shaded the part that corresponds to the area under the curve that characterizes the probability that we're interested in. In this case, the area between these two boundaries, the 0.475 and the 0.515. We then used the Z-score formula to find the corresponding values of the standard normal that will have the correct probability properties that we need to calculate this area. We then, so in other words, we're able to state the probability statement that is of interest to us from the problem. We are able to restate it in terms of the standard normal. And then using this procedure here, we were able to calculate that area by reading off the values from the standard normal, performing the subtraction. Okay? I hope you all have enjoyed this example, and I look forward to seeing you again soon. Thank you so much.